So what is big data? Big data is a field of study that treats ways to analyze and systematically extract information from data sources that are too large or too complex to be dealt with by traditional data processing application software. Big data is kind of relative. If you really have to think hard how to handle or analyze the data, then it's big data. However, just because data is big doesn't mean it still can't be low quality and hold minimal value. There are 6 dimensions of data quality that determine the reliability, validity, and the measure of value and insight that you will be able to extract from the data itself. These dimensions are: number 1, accuracy. How well does a piece of information really reflect reality? Number 2, completeness. Does it fulfill your expectations of what's comprehensive to represent the patterns or trends you're looking for in the data? Number 3, consistency. Does information stored in one place match relevant data stored elsewhere? Number 4, timeliness. Is your information available when you need it and as often as you need it? Validity. Is information in a specific format and does it follow business or classification rules, or is it in an unusable format? Number 6, uniqueness. Do instances in the data appear more than once, or are there duplicates? Working effectively with big data requires you to be able to accurately define the key characteristics of the data itself. When describing big data, we generally use the 6 V's, including number 1, the volume, the measure of the actual amount of data. Number 2, the variety, the types of data, unstructured, semi-structured, or unstructured. Number 3, velocity, the speed at which big data is being generated. Number 4, veracity, the degree to which big data can be trusted. Number 5, the value, the measurable clinical or business value of the data collected. Number 6, variability, the distribution of the data itself. So working on data projects, whether it be machine learning, prediction studies, or image classification, requires working in multidisciplinary teams across a spectrum of skill specialisms, such as one could be a subject matter expert identifying the problem case itself and the key value measures. Another one could be the skilled technical data wranglers and machine learning engineers. All professionals involved at any level should be able to describe the data comprehensively for effective communication about the project. How do we store big data? You guessed it, databases. There are many different types of databases, each with their advantages and shortcomings. The type of database that is appropriate to store any particular data set depends on several factors. Number 1, the amount of data in your data set. Number 2, the type of data in your data set. Number 3, what the data is being used for. Number 4, the complexity of the queries that need to be run on the database. Number 5, the technical programming expertise of the person handling the data. Number 6, the security needs to keep the data safe. Number 7, how often the database needs updating. Databases are generally interacted with via a structured query language, which is a programming language used to run search queries to highlight relevant data in the database for analysis. Learning the basics of SQL is straightforward and shouldn't take too long. Experts of databases are called data engineers and data architects. So what are the main types of databases? Relational database, the most common type of database. These databases are characterized by a set of interconnected tables with unique identifiers per instance or person. The structured query language, SQL, is the standard user and application program interface for relational databases. There are various simple operations that can be applied over the tables, which allow you to extend, join, and modify any of the data. Centralized database. The information in this type of database is stored at a central location, and the users from different locations can access the data. Distributed databases. The information is stored in different locations and they're connected. Personal database. The data is collected and stored on personal computers, which are small and easy to manage. Commercial databases. These are the paid versions of databases that are designed for commercial users, such as companies with specific subject and security needs, so they can be customized for the user's needs. Commercial databases include Oracle, IBM, SAP, MySQL, amongst others. Cloud databases. A cloud database is a database that typically runs on cloud computing platforms such as Amazon Web Services, Google Cloud, Microsoft Azure. Database services can take care of scalability and high availability of space. There are various benefits of cloud databases, some of which are the ability to pay for storage capacity and bandwidth on a per user basis. They provide scalability on demand along with high availability. Object-oriented databases. An object-oriented database is organized around software objects rather than actions and data rather than logic. It uses object-oriented program fundamentals. Small data. If there is big data, then what about small data? A key concept to keep in mind when planning how best to distill big data into actionable insights is the concept of small data. Our brains are astoundingly good at making particular types of multidimensional dynamic decisions. However, they are also astonishingly bad at making some decisions that involved probability theory and certain types of mathematical complexity. An overarching goal of managing big data is converting it to small data so we as humans can process it to make better decisions. So what is small data? Data that is low enough volume and low enough complexity and organized in such a way to make it fully comprehensible for humans to deal with effectively. There are many theorems on the technical definition of small data, and they revolve around the working memory of human beings being 7 plus or minus 2 distinct objects, coined by the psychologist George Miller. EHR, the Electronic Health Record. EHR is the functional unit of all machine learning, predictive analytics, and big data in healthcare. There are 5 main forms. Firstly, structured data such as blood test results. Number 2, semi-structured such as a patient questionnaire with a drop-down box and boxes for qualitative responses. Number 3, unstructured data such as medical consultation text box. Number 4, radiological, image, or binary DICOM PACS data such as an X-ray or a CT scan. Number 5, streaming data such as ECG data on a continuous monitor in the ICU. Each type of electronic healthcare data requires a different mechanism to enable the data to be processed and utilized for the purpose of machine learning, data mining, or data exploration purposes. The correct and most suitable mechanism or technique to process the data is dependent on the building blocks of the data itself and what the goal of the processing actually is. Here are 4 examples. Number 1, numerical continuous data being used to predict an actual value such as length of stay of a hospital patient. There are many techniques that could be used here, but a particularly useful type would be linear regression. A second example is using numerical continuous data to be used to predict a class, such as whether or not a patient is diabetic or not. A suitable model to use here would be logistic regression or a support vector machines model. Number 3, third example, is pixelated image data being used to predict classification of a new image, such as a radiological X-ray with fractures being used to classify if there are or not fractures in the new X-ray. The type of technique that would be considered appropriate here would be broadly called a convolutional neural network that uses microfilters to place the pieces of the puzzle together. For example, filtering parts of the femur bone to identify fracture lines in common areas of the X-ray. Number 4, unstructured typed text from a medical consultation being used to predict the categorical diagnosis of a patient in the consultation. An appropriate technique to use here would be to give a score based on the ordering and the frequency of specific words to amount to a probability corresponding to a specific diagnosis. This would be a type of machine learning technique called natural language processing.